Hello, on August 29th. Alright, let's do this. Sudoku. Determine if it's valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits without repetition. Each column must contain the digits without repetition, and each 3x3 must contain without repetition. A Sudoku board could be valid, but is not necessarily solvable. Only the filled cells need to be valid according to the mentioned rules. So this is actually very easy. All we need to do is just go all the rows, go all the columns, and go all the things. So we will write 3 separate loops. I think the most difficult part is, I wonder if we can generalize it. You know, top, left, bottom, right, generalize it so we can run all 3 with the same function. Let's try. That is a very different method. I don't think I used the same method before. I think before I was just, just do as what we told. But this time I want to do it slightly differently. Hold on, let me write it first. So this is 36. Instead of writing 3 sets of logic to validate, how about we write one logic, right? One generic, and which can be applied, right? Which can be applied to 3 scenarios. Let's do this. All right, so to do this, what we need is a boolean. Okay, check valid. So what we need, I need a ij, right, and pq. Okay, and then the grid char. Interesting. So ij is the coordinate. Just ij is the top left cell. pq is the bottom right cell. Okay, so what we need to check is if there are any repetition. So what we do is we'll get a vector 1 to 9, so we need 10. So int boolean scene 10, and will be false, right? And now I have ij. So what we're gonna do is all right, I don't like ij. Let's go uv. Okay, uv. Alright, and now here we can say for int I equal to, so I start with u, I smaller than p, right? I plus plus. For int j, start with v, j smaller equal to, my bad, smaller equal to q, j plus plus. If scene board ij minus 0, return false. Otherwise, scene board ij minus 0 go to true. So we'll do this, and now I return true at the end. Okay, so with this, well, so we can say check horizontal, check not horizontal, check rows, right? And then we also have check columns, check inner 3x3. For int I, 0i smaller than int n, for.size I smaller than n, I plus plus. If not, check valid. Okay, let's so I 0 I n minus 1, right? And then board. If it's false, we'll return false. Okay, check columns. J 0 j smaller than n, j plus plus. If not, check valid. So top left is going to be 0j, bottom to be n minus 1j, board, turn false. Okay, this is more interesting. Check 3x3. So it's a 9x9, right? So we're going to say for int I, 0i smaller than n, I plus equal to. So I start 0, 1, 2, 3. I place it with 3. Right, and then we have an I. So we also need j. Okay, int j, 0, j smaller than n, j plus equal to 3. Okay. If not, check valid. So ij, top left, bottom right, I plus 2, j plus 2. Alright, I plus 2, j plus 2. 3, and 6. Yeah. Board. Check valid. I, j, I plus 2, j plus 2. Why this one is okay, so blah blah blah, and at the end we'll return true. Okay, so that is generic. Let's see if this generic works. I think that means we're out of that is interesting. How? Boop 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 boom 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 boom. Let's see the scenario. So it'll be 0. So basically in this case, I will be the same. Alright, I will be the same. So we're basically doing the same I, and then j will go from 0 to n minus 1. Maybe it's seen. Oh, you forgot something. If oh, okay, yeah. I know what I got wrong. If seen, let's do char. I have v already. Char c board ij. So I'm reusing it many times. So if c is equal to this, continue. We don't care. Otherwise, we'll do c minus this. You see, like, this is the benefit of doing unexpected expression. What do you mean unexpected expression? Oh, it's a dot? Huh, I didn't realize it's a dot. So the benefits is because it's generic and everybody's calling the same function, we don't have to worry about changing 3 times. We change only once and then everything works. That is the beauty. I'm not sure why it's so slow, but it's okay. Well, bless the soul of today's question. It's actually quite simple. When was the last time when I did it? 2018. That was the first time when I handled this problem. 2018. Lord. And then 2021, 2022, 2025. So yeah, that's how long I've been doing this. 2018 is freaking 7 years ago. 7 years ago. Wow, look at what I was doing back then. Holy moly. Holy moly. 7 years ago. That was... I don't know, man. Things are... Things are very different back then. 7 years ago. October 19th, 2018. Have I started? I think I know where I was back then. I think I do. That was in the studio apartment. One of the worst places I've ever lived. Actually, I shouldn't say that. The worst place I've ever lived is a mobile home. It's a trailer home. It's a one tiny room in a trailer home. That was the worst, but it also has some good memories there. Yeah, that was the worst place. But this, yeah, I think this is in the studio apartment. And I think I already started, I went back to college. I worked from 2017 until 2018. Yeah, 2017, I think it's May. 2017, May 2017 until around April 2018. That's when I worked as a coach. Also, I mean, it was an experience, but then you realize, it's not for you. And after that, I decided to go back to school, and I didn't know about LeetCode actually at that time. I think around when I went back to school, June? Yeah, I think it's the summer semester. Yeah, I think I enrolled in summer, so around June, late May, early June, when I went back to school and started, just playing around. I think this is and then I learned about LeetCode. Where did I learn about LeetCode? I don't even remember. I don't remember how I learned about it, but I did. I learned about it, and then I started just working on it. I think back then I was also doing Project Euler, both every day. Yeah, I still have time back then. All right, do we have more test cases? 507. 504, we added 3 more test cases over 7 years. What was the method back then? Ooh, bit. Oh, wow. Oh, wow. Oh, it's pretty smart. Yeah, otherwise we have a mask. check row. If check row I, so the mask, it cannot be, okay, yeah, so it cannot be, and then I update the row, and then we check column, it's the same thing. Column, where's column? Oh, you do this. So this represents each row, this represents each column. Holy crap. Alright, so this column always starts with 0. And then I do mask. Yes. For the column, its mask is this. So I check the column as well. If not, I put at this column. And then the 3 by 3. What the hell? This is to compute which one it is. Oh, holy crap. Alright, I don't think I can come up with this. A bit manipulation. Alright, challenge accepted. Let's bit manipulate it. Wow, this is actually very good. And this is when was the problem? 2021, August 18th. Bit masking. It's a better solution. I agree. 820. Oh, it's almost 4 years ago. All right, let's implement it. So this is the bit masking solution from 2021, 820. Right. Since each row, column 3 by 3 only has 9 elements, we can use an integer. Right? Okay, it's a bit mask to represent its state. For the next value, right, we'll check if it has been seen already in the bit mask. And this will be faster, right, than checking one by one. Actually, this is probably not O(n) squared. It's O(n) squared to run this. Yeah, I was wrong. This is not O(n) squared. Hold on. This is O(n) tripled. Because you have O(n) squared for this. And then you have to run another one. So, right, it's O(n) triple. Actually, no. This is O(n) squared. Inside, you have to do another 3 by 3. So, yeah, technically this is O(n) tripled. O(n) now. O(n) to the 4th. Triple, triple, this is the 4th, right? Only taking O(n) squared. All right, implemented. So we need a state. So row. Nine. Column 9. What we call the last one, inner 9. And then we'll go through everything. Yeah, I equal to 9 I smaller than I equal to 9, I equal to 0, 9. Yeah, we just do 9. We know it's 9 plus right into j, 0 j and smaller than 9, j plus plus. Alright, here's the thing. We have the mask. Okay, mask shall equal to 1 left shift board. Oh, hold a second. Board ij. Ooh, if board ij is equal to dot. Right, we'll continue because we don't consider this. Otherwise, we'll left shift. This is the mask. Okay, this is the mask. And then we need to check if, right, if row I and this mask is not equal to 0, return false. Right, so this just means the row has already, which I think I can do this, right? This is 0 is evaluated as falsy. So this means the number has been seen, the value has been seen before. And then we say row I. Okay, probably, yeah, let's do this. Row I or equal to mask. And then for column j, if it's not for column j, if column j and mask return false, right? And then we'll do column j equal to mask. And if index in II, right? So inner, what's the index for the inner? That's 0, 1, 2, right? 3. So I divided by 3. So I divided by 3 will give us this, and then we need to plus. Do we plus j divided by 3? Let me think. So j at a certain position, I divided by 3 give me the row, and j divided by 3, that's 0, that's 1. Okay, yeah, that looks alright. And then we say inner, if inner II, right, and mask return false, and then inner II or equal to mask, and then in the end we'll return true. Alright, let's give this a shot. Just win it. Ooh, first one is not right. I have no idea. Not sure. I have some suspicions. This is always suspicious every time, but probably not. Yeah, it's not because of this. I mean, we can debug, but I don't know if I want to. Let's take a look at this one. I think this is the only suspicious one. So 0, 0. This shouldn't be 1. Yep. This does not look right. So I 0 J, so 0 0 0 1 2. How come I become 1? And this way, what? Ugh. Hold on. All right. Let's take a look what went wrong. So we skipped this. Yeah, that's actually right. 0 0 and we skipped 0 1 2 3 4. Oh, that's actually right. My bad. So this might actually be right. This might actually be right. Yeah, should be 0 0 1 0 1 1 1. Yes, and then 0 1 1 1 0, and then wait, hold on, 0 1 1 0 0 2 Wait, hold a second. How about the remaining? Is this all the values? 2 3 4. I think it didn't show me all the values. No, I think it's because it returned false somewhere. All right, so where do we stop? 0 0 0 1 0 1 1 1 0 0 2 0 0 0 0 2. How come this become 1? This should be 3. This should be 3. 0 1 2 3. Yep, that is not right. So this needs to be this times 3. times 3. That's more like it. Yeah, I knew it. It's the issue with this computation. There we go. That's how we'd expect it to be. That is how we expect it to be. It's 0 milliseconds. Okay, gut. So I just swap this line. Oh my goodness. Alright, I don't need to swap this line. I know what this is. Hold on. There we go. Okay, that'll be it.